Our bodies are exquisitely complex machines. In our efforts to care and improve them, we look to those who push the limits of what is humanly possible, such as athletes. Now, you would say, what can we learn from them if every athlete is different? If they achieve peak performance through customized diets, training, and technology. As it turns out, we too are all different. That is to say, there is no single lifestyle, no diet, no medication that will work equally well for all of us. If this is so, how can we get the best out of our bodies? Now, imagine a virtual human, not made of flesh and bone, one made of bits and bytes. And not just any human, but a virtual version of you, accurate at every scale, from the way your heart beats down to the letters of your DNA code. You know that many drugs only work well on some people and can cause serious side effects in others. The reason is variations in DNA, our genetic differences. But we understand how these DNA differences change the building blocks of your body, the proteins, and we can simulate in a computer how drugs interact with them. By testing drugs on your virtual body, your doctor may eventually be able to test a wide range of drugs and select precisely the right one to suit you. But sometimes, choosing the right drug is not enough. We must also be able to deliver it to a precise target in the body. Take inhaled drugs, for instance, which can end up in the walls of your nose or at the bottom of your lungs, depending on the intricacies of your particular respiratory system. Using supercomputer simulations based on scans of your lungs, we can predict with high precision where particles will flow, and then design devices that can deposit drugs exactly where your body needs them. Well, obviously, mastering drug delivery means controlling the body's main transport network, your circulatory system. By simulating the movement of red blood cells and other cells, we can understand important protective processes, like those that prevent blood loss after an injury. Virtual humans could help doctors to plan risky surgery too. They could be used to work out how to reach an aneurysm deep in the brain that is at risk of rupture, which could cause a stroke. Surgeons could then try out the best treatment or implant to suit the location and shape of that particular aneurysm. They could even double-check that the implant will not cause problems, such as clotting, before they try it out on you. Physics, chemistry, and biology intertwine in your circulatory system to drive the most remarkable pump that evolution has ever created, the heart. To create a virtual heart, processes have to be modeled at multiple scales, from the contraction of muscle to the blood flowing through its chambers, to the movement of charged atoms during a contraction. Virtual hearts already beat within supercomputers, where we can test the effect of different drugs or pacemakers, but also more fundamentally, to understand the way an individual's heart works. Your virtual avatar will not only be built in your image, it will also move like you. We can use it to calculate the forces and the mechanical stresses that are constantly induced on your bones, and predict the risk you will suffer a fracture. Doctors can also use virtual humans to work out how diet, exercise, or drugs can help those with brittle bones. And what if we go even further than treating disease, using virtual humans to prevent illness? Within a supercomputer, many virtual versions of you can explore small changes in your lifestyle and how they affect your health, aging, and quality of life. Virtual humans, helping you to figure out the very best that you can be.